Alright, welcome back. In this tutorial, we're going to determine whether the circles intersect internally, externally, or they do not intersect at all. Right, before we look at the hints on how to deal with this, let me just give you the different scenarios that we may have. Right, we may have the circles touching externally. How will they look like if they touch externally? If circles touch externally, they will look like this. And then we can have the circles touching internally. And then if the circles touch internally, it means the circles touch like this. And then we can have a situation where the circles do not touch at all, and the smaller circle is outside the larger circle, and it will be like this, where the circles do not touch at all, and the smaller circle is outside the larger circle. And then we can have a situation where the circles do not touch, and the smaller circle is inside the larger circle. And then we can have the last situation where the circles intersect at 2 points like that. So how do we deal with this situation? Before we go further, I would like to say this. The tips that I'm going to give you here may not be enough for you to answer the questions. So these tips that I'm going to share with you will assist you. So try to understand the context that you're given and use these tips that I'm going to share with you with the context to answer the question. Before we discuss the tips, I would like us to look at the variables that we're going to use for this tutorial. We're going to use the capital letter R for the radius of the larger circle, and then we're going to use the small letter r for the radius of the smaller circle, and then we're going to use small letter d for the distance between the centers of the two circles. Right, so these are the three variables we're going to use as we discuss these tips. Right, the first situation is said that the circles may touch externally. When the circles touch externally like this, we say that the sum of the larger radius and the smaller radius will be equal to the distance between the two centers. We can even say that if we subtract the small radius from the distance between the two centers, we'll get the larger radius. Like this, you can say r is equal to d minus small r. Or you can even say, if we subtract the larger radius from the distance between the centers, we'll get the smaller radius. So you can say r is equal to d minus r like that. This may assist you to realize that the circles touch externally. Right, this is a good example here. We have the larger circle having a radius of 5 and the smaller circle having a radius of 3. And then if we add these two radii, we get the distance between the centers, which is 8. And then we say there's a situation where the circles may touch internally. And then when the circles touch internally like this, we say that the distance between the centers is equal to r for the larger circle minus r for the smaller circle. Right? This is the distance between the two centers. And then we say the r of the larger circle minus the r of the smaller circle. We'll get this distance between the centers. Or you can even say that the distance between the centers plus the r of the smaller circle will give you r of the larger circle. That's another way of doing it. Okay, like here's a good example. If you say 3 plus 5, 3 is the distance between the centers, and then 5 is the radius of the smaller circle. If we add them, they give us the r of the larger circle. Or if you say r of the larger circle, which is 8, minus r of the smaller circle, which is 5, it will give you the distance between the two centers. So this also may assist you to see that these circles touch internally. And then the third situation is said that the circles may not intersect and the smaller circle is outside the larger circle, like this. This one is very clear, I think. If you add this and this, obviously, they won't give us this distance here. Okay, so you're saying the distance between the centers is bigger than the sum of the larger radii and the smaller radii. It's very clear, isn't it? For example, we have the radius of the larger circle being 5 and the radius of the smaller circle being 3. If we add these, we're getting 8. But the distance between the two centers is 10, which is greater than 8. Okay, this shows that the two circles do not intersect and the smaller circle is outside the larger circle. And then the fourth situation, we say that the circles may not intersect and the smaller circle is inside the larger circle. And then if we look at this diagram, this may assist you. We can see that if we add the radius of the smaller circle and this distance between the centers, we won't get the radius of the larger circle. You see that? So we can say r plus d is less than the radius of the larger circle. Or we can use this. The distance between the centers is less than the radius of the larger circle minus the radius of the smaller circle. Like here, the radius of the larger circle is 5, and then the radius of the smaller circle is 3. If I say 5 minus 3, you get 2, which is greater than this distance between the centers because there's this gap that is to be accounted for here. So the distance between the centers plus the radius of the smaller circle, if you add them, they won't give you the radius of the larger circle. It is going to be the sum of these two is smaller. So you can use this or you can even use this. And then the last situation is that we have the circles intersecting at 2 points, like overlapping. When they are overlapping like this, we say that the distance between the two centers is less than the sum of the larger radius and the smaller radius. If we add them, these two, we'll get an answer which is bigger than the difference between the centers because these circles are actually overlapping. So the distance between the centers is sort of what? Is sort of reduced. Remember, when they touch it externally, we say that the distance between the two centers is equal to the radius of the larger circle plus the radius of the smaller circle. But now when these two overlap, we're actually reducing the distance between the two centers. So the distance between the two centers becomes smaller than the sum of the radii. You have to remember these 5 situations when dealing with the relationship between two circles. Do they intersect externally, internally, or they do not intersect at all? If they are intersecting, are they intersecting at 1 point or at 2 points? You can use these tips to answer questions that involve this concept. Right, let's look at an example. A circle with this equation is smaller than the circle with this equation. So it means this one is a larger circle, this one is a smaller circle. Right? Prove that the smaller circle and the larger circle do not intersect and the smaller circle is inside the larger circle. So if the smaller circle is inside the larger circle, then we're saying that the distance between the two centers must be less than the difference between the radius of the larger circle and the radius of the smaller circle. Or you can say the distance plus the radius of the smaller circle. These two will not give us the radius of the larger circle. They'll be actually smaller than that. Okay, so you can use any of these. The equation of the larger circle has to be written in standard form. It has to be written in the form x minus a squared plus x minus b is equal to r squared, isn't it? So what do? We have our x squared. Let's bring these ones closer to each other. X squared plus 32x. And then we have y squared plus 16y. And then plus y squared plus 16y. And then is equal to negative 240. Right? And then we complete the square, these two. So it becomes x squared plus 32 x, and then we find half of positive 32, which is positive 16. Then we square it and add it on both sides of the equation. So it's going to be plus positive 16 squared. And then this side, negative 240 plus positive 16 squared. Okay? And then we do this one, complete the square there. We find half of 16 here, which is 8. So we say plus y squared plus 16 y, and then plus positive 8 squared. And then this side also plus positive 8 squared. right? I usually write the signs here to assist me, okay? Right, becomes very easy when you do that, right? So now, when you're factorizing this, you can do the longer way, but remember we did this. Like if you square a binomial, what do you get? Let's say if you say a plus b squared, you'll get a squared plus 2ab plus b squared, isn't it? So that is that form. And then we're moving from this form to this form, okay? So it's going to be square root of a squared here, you get a. Square root of b there, you get b. So here it's going to be the same thing. Here is going to be 2 times a times b. Same thing here. 32x here is like 2 times x times 16. So this is the same form. Or just take this. You know, I'm taking x here, and then I'm taking positive 16 there. I form the bracket. Becomes x plus 16 squared. Then plus. Here you take the y, take the positive 8, form another bracket. And then y plus 8, and then square the binomial. Just like that. And then if you put this in the calculator, you get your 80. Now we can see that for the larger circle, let's call it what? The center of the larger circle, let's call it B for the bigger circle. So B, the center of the larger circle is going to be negative 16, then negative 8. And then radius of the larger circle is going to be square root of 80, which is actually 4 root 5. So we have the center, we have the coordinates of the center, we have the radius. And then for the smaller circle, let's call it smaller circle S. And then the coordinates of the center will be negative 14 and negative 10, like that. Negative 14, negative 10, like that. And then the radius is going to be square root of 20, which is equal to 2 root 5. Because remember, this is like r squared. This is like r squared. So to find r, we square root both sides. And then we get our what? We get our r. Okay? Right now, we have the larger radius, we have the smaller radius. We need to find the distance now between the two centers of the circle. We're going to use the distance formula. Right, SB is going to be the square root of x at S is going to be negative 14 minus negative 16. Negative 16, right, squared, and then plus. We're looking at the y's now, negative 10 minus negative 8, like this. And then squared, like that. You can put this whole thing in the calculator. You get that SB is equal to 2 root 2. So now this is the distance between the two centers. And then if the distance between the two centers here, we can see that this distance between the two centers, which is SB, is less than r minus r, the radius of the larger circle minus the radius of the smaller circle. Okay, right? Or let me write the number. 2 root 2 is less than 4 root 5 minus 2 root 5. See that? Because this will give you 2 root 5, which is greater than this. Or you can say, if we add the distance between the centers, 2 root 2, plus the radius of the smaller circle, 2 root 5, right, won't get 4 root 5. This is actually less than 4 root 5. Okay, meaning that the sum of these two, the distance between the centers and the radius of the smaller circle, if we add them, they give us a distance which is less than that of the larger radius. Okay, so it shows that these two circles, they do not intersect, and the smaller circle is inside the larger circle.